Hi everybody, this is Brian O'Connor. Welcome again to one of my bite-sized videos on, this time, layer 2, the data link layer of the 7-layer network model. So what we're going to have a look at here, we're going to have a look at what is the data link layer. We'll have a look at the data link sublayers. We'll have a look at data link frames and what devices actually live at the data link layer. So as we can see, what we have is we have the 7-layer network model, and within the 7-layer network model we have layer 2, and layer 2, as we can see here, is the data link layer. And the data link layer, if we move this forward, as we can see, it's responsible for the physical address of the device's network interfaces. Now this could be a router, this could be a device such as a PC, a laptop, it could even be something like your tablet device. And the MAC address is a 48-bit address which is unique to the device. And this is based on a 48-bit address, as we've already mentioned, and it's broken down into a hexadecimal address. And as we can see, it's made up of 6 different blocks of numbers. So what we have is we have the first 6 digits are actually unique to the manufacturer, and then the 6 numbers after that make that card unique on the actual network itself to that manufacturer. What we also have is the data link layer is responsible for the transmission and receipt of the bits from one node to another. And the data link layer defines the logical topology where all of the nodes may include multiple physical subnets. So what I may have is I may have 2 physical subnets divided by a device called a bridge, or what I might have is I might have multiple devices all connected centrally into a device called a switch. And the data link layer organizes the streams of zeros and ones that come from the physical layer into structured units that we call frames. So if we have a look at this, we can see that we have the data link sublayers. So within the data link layer itself, we break that then further down into 2 separate sublayers. At the top there, we can see we have the logical link control, and the logical link control provides a standard network layer service interface regardless of which MAC address sublayer protocol is used. And then what we get, if we have a look further down, we have our MAC address control, or media access address control, or the MAC layer. And the MAC layer is broken down into 2 separate standards. We have the IEEE 802.3, generally used for wired, and we have 802.11, generally used for wireless. What we also get at the sublayer level is we get the definition for our logical topology. Now we can have our devices set up in a bus, or we can have our devices set up in a ring. We'll have a look at that in a later bite-sized video. The media access method is also defined at the MAC layer, and this can be contention based such as Ethernet, or it can be token passing such as token ring. We also get the addressing defined at the media access control level, so that will be again the MAC address that's assigned to our network interface. It gives us the frame format, and it also as well gives us very basic error checking. The data link layer itself is not responsible for retransmitting data in the case of any corruption. That's handled by the higher layers that we'll cover in later videos. So moving this forward. So the data link frames itself, so what we're defining here at the layer 2 level is we're defining these frames, and the frames are really the things that are being passed backwards and forwards between the devices to allow data to be sent. So each frame contains a network layer packet, and that's called the payload, so that's the actual data. Data link layer adds some control information to the payload, and it does that by adding a header, and within the header we have the destination hardware address. We also have the source address, so we're not talking about TCP/IP. For anybody that already understands that type of addressing, we're talking about the physical addresses. So on a separate link of cable, 2 devices communicate with each other, they will communicate with each other's MAC address. If 2 devices are separated by a router, one device on the source network to the destination will pass its data to the router, and then the router will decide what to do with that data. And again, we'll cover that in a later little bite-sized video. What we've also got right at the end of the packet, we have our error checking, and it's very basic error checking. It's going to check for things such as maybe the fact that we have a corrupted frame within the packet. So it is very basic error checking, but again, the data link layer is not responsible for retransmitting that damaged frame onto the network. What we also have at the data link logical topology media access. So what we have at this point here, the data link layer is going to determine how multiple nodes can share access to the network media. And as we've already mentioned, we have the bus and the ring-based topologies. So bus-based topologies use contention methods, and ring-based topology use token passing access methods. I will cover that in a different bite-sized video. And finally, what we have is we have our devices actually used at the data link layer. And the first device we have here is we have the network adapter or network interface card, and the network interface card joins a host of the network media. Now that could be cabled or that could be wireless, and it enables it to communicate over the network by assembling and disassembling the frames. We also have bridges, so a bridge allows us to join two network segments. It minimises the performance reduction of having more nodes on the same network, because what we do is if we have two separate segments, we only need to pass data across the bridge if required. So that saves us having to send packets to every single device. And a bridge will have multiple ports, each of which will function as a network interface. We then have switches, and this is an advanced type of bridge. It's a multi-port bridge, and a switch creates links between large number of nodes more efficiently by creating things that we call collision domains. What we have finally is we have the wireless access point, and a wireless access point allows nodes with wireless network interface cards to communicate, and it creates a bridge between the wireless networks and wired networks as well. And that's the end of this quick little bite-sized introduction to what is the data link layer or layer 2 of the OSI 7-layer network model. So thank you for watching, and we will catch up in a later bite-sized video. Thank you.